Hi, this is lesson 4.5, Taylor Shaw. Calculus Extended, we're going to do area between curves. And so that's what we want to look at right now is the area between two curves. So this is the definite integral, which finds the area under the curve and gives a signed area, some that's above the x-axis positive and some that's below the x-axis negative. And then we also end up with some zeros. However, if you're asked to find the actual area, area has to be positive. So if we want to do the area between two regions, or I'm sorry, between two curves, we take the f of x minus the g of x, where the f of x would be a top function. It's going to be above the g of x, and then the g of x would be the bottom. So we call this one the top, this one the bottom. And that's all we're going to do. Then for functions of x, we want to go top minus bottom. That's what we just said. But then sometimes we're going to have functions of y, and we're going to go right curve minus left curve. Now this is very important. This dy tells us with respect to which variable we're dealing with. And this a and this b are both y coordinates. Here, this a, this b are both x coordinates because this tells us that we do have this in x. So let's look at example number 1. Find the area of the region bounded by y equals x squared plus 2, y equals x equal to 0, and x equal to 1. When I see these four equations, those are all going to be on the edge of my region. So make sure that that does happen. That's probably the trickiest part of all this. Then I'm going to take the top curve minus the bottom curve. So here's my top curve, which would be the x squared plus 2, and then here would be my bottom curve, which would be the y equal to x. So what I like to do is I like to draw this Riemann rectangle that tells me top minus bottom. I call this a cut. And so with this cut, it tells me all of the rectangles that I'm adding up as I go across this region. And that helps me to say, okay, I got to take the length of this thing, which would be the top value minus the bottom value. And so that's what I have right here, top minus bottom. Then I put this into the integral. So I do my limits of integration, which would be my 0 to 1. So that's my lower limit of integration. My upper limit of integration would be the 1. And so then I have the x squared plus 2. This function right here is my top. And then minus my bottom, which would be the x function right there. So this is the integral that I'm going to be using for this. Then if I go on, I can take the antiderivative. Antiderivative of x squared is going to be 1/3 x cubed. 2 is going to be 2x, and then minus x would be minus x squared. And then that's going to be evaluated from 0 to 1. And if I plug that in, plug in the 1, I'm going to just get this value right here. I don't know if I made an answer for that or not. I did not. And I got 1 5/6 for that. Let's go on to example number 2. Now what happens if my curves are x in terms of y? In other words, I'm going kind of right to left with these things. And so what happens sometimes is that we want our cut to be this way right here. Now when I do this, this little piece of this rectangle would be what we call dy. Not dx, but dy, because I'm on the y-axis for this length. And so when I take this and set this up, I'm going to do an integral in terms of y. And we'll go right minus left. I could go top minus bottom, but then I'd have to split it over this piece right here because my top minus bottom would change. So let's do it right minus left and see how we can do this. So we have functions of y. Find the area of the region bounded by x equal to y squared minus 3, which is the sideways parabola, and I have this over 3. These increments aren't, well, they're split up small. But this would be -3, and then y equals x plus 1 would be this line. So I'm trying to find the area of this region here approximated by these rectangles. Now I want x in terms of y. This one's already set up for me. This one, however, I solve for x in terms of y. I get y equal to 1. So I have the right function. Oh, that's the right function. That's the left function. So the first thing that we want to do is find our limits of integration. I need to find this intersection point and this intersection point. How do we do that? Well, we set the two equations equal to each other, and then we go ahead and solve them. So if I solve the intersection points, I'm going to get y squared minus 3 is equal to y minus 1. Then if I solve that quadratic, get everything on one side as such, then you can factor. And then once I factor, I can solve that, and I get 2 and negative 1. Those are y coordinates. Now when I set this up in my definite integral, dy tells me that I'm going to use my y coordinates for this. And if you look up at your picture here, where's the 2? Well, the y being 2 would be up here, and then the y being negative 1 would be down here. So I'm going to make all these cuts run from negative 1 all the way up to 2. So that's what I'm doing. So if I go back here, I can set negative 1 to 2, right minus left. That's my definite integral that I do. Now look at there, I got a mistake. I'm going to have to come back and change that because I flipped these things up. So then I'm going to flip up this next one, negative 1 to 2, and I just simplified that. So now I take the integral of each one of these pieces, and I'm going to get negative 1/3 y cubed plus 1/2 y plus 2y evaluated from negative 1 to 2. And if I finish this off, I'm going to plug in the 2. I'm going to get an 8 over 3, and so on, and then you're going to end up with 4/5. You should be trying this yourself. Now, one of my major points here was that this was with respect to, I don't know if I can change this thing over to y or not. Oh, there I can. With respect to y, so this would be y equal to negative 1. You can even put in y equal to negative 1 and y equal to 2 if you wish. But it has to be in y, so this dx is wrong. And then here's another one that should be dy. Okay, so if it's in with respect to y, my small little piece of y here turns into this dy there. That's where that's coming from. Okay, so that's how we can solve that out. Sorry I went through that fast, but I'm sure that you can do that. Now let me show you how to do this on the calculator. So you can go Menu, Calculus, this is on the TI Nspire, and we want to do integral. The integral is going to be from negative 1 up to 2, and then I'm going to have the definite, or the integrand, to be my y minus 1, which is my right, minus my left. And so when I do minus my left, this is going to give me y squared minus 3. There you go. Then I just plug this in as such, and I should get 4.5 when I do that. That's what I get. All right, that's kind of fun. You can also do it from this menu here, and then the definite integral is one of these, this one right here. Okay, so that's how you use your calculator and can see that. Okay, I'm going to make this one, example 3, a little bit of calculator intensive. So we have some concerns here because top minus bottom, well, let's look at the curves first. We're going to find the area between this curve and this curve. So I have one region here and one region here. Now if you notice, this right here is my parabola, so this would be my G. And G changes from the top in this region to the bottom in this region. Oh, so now I got top minus bottom, which is one scenario, and top minus bottom, which is another scenario. So I need to set up two integrals, for one for this piece and one for this piece. Otherwise, I won't get out my positive values like I would like to. So we can go ahead and solve for the intersection points. And what I'd like to do is, if I can show you some of this, we go f of x is equal to g of x. Make sure you show setup. And then when you solve this, you do get these three values right here. I'm going to show you this on your calculator. So I have these two graphs in, and then I'm going to go to Menu, and I want to analyze the graph, and I want to find the intersection. So the lower bound, I need to go to the left. I can click there, and there's my value right there, negative 2.0248. I probably want to carry this one out as much as I can. Otherwise, I'm going to get intermediate rounding as I go along. And then I can do that again for the other 2 points. This one's obviously, maybe not, but it's obviously 0. And then the other one that I find over here, I did the same thing, 2.0248. That would be the x coordinate. If you ever want to get more decimal places here, you just hover over it, and push the plus symbol, and you should get more decimal places. I don't know why I just didn't get more, but that's what should happen. So let me show you on the calculator. Well, let me show you written out first what we're going to do, and then show you on the calculator how to find all this. So if I do this to get my values back, this is my definite integral that I'm going to have. Negative 2.0248, which we found would be this point here, and I'm going to go up to 0. And this is all dx, so I have that there. This first piece is going to be f minus g, because I got the top minus the bottom in this situation. This is f, this is g. Then if I go over here, it just switched itself around. So I got g minus f, and that would be from 0 to 2.2, whatever that number is. Okay, so that would be my definite integral that I do have. And if I keep on doing this, now what's nice is that I have f3, which is my f of x, and f4, which is my g of x, already in my calculator. So I can go to a calculator page, and I can just type this stuff in. Now also what I can do is I can copy this value. So I'm going to go over the top of it and copy it. So when I set up this integral menu, calculus, integral, I can just go and paste. That's not what I wanted to paste. I thought I could copy and paste that value. I can't. So I just typed that in. And I used the function values because I had those already entered on my graph. So I don't have to retype everything. So then I just hit enter and I get that number there. That is the left-hand piece. Now if I want to do the right-hand piece, I can just jump on top of that and change all this stuff now. So I switched my limits, but I did not switch my top minus bottom. What's going to happen if I don't switch my top minus bottom? I'm going to get, I'm going to get a negative value. That is not right. Okay, so if you get a negative value out for area, then you did something wrong. Probably you had these things in reverse. So I'm going to have to switch those around to get that positive value, or I guess I could take the absolute value of that in the end. So I did do top minus bottom rather than bottom minus top. That gives me my positive value. That's why we do this top minus bottom, because it will always give us that positive value. So if you add those two together, you're going to get 8.405. That would be your final answer for that. And that's your answer there. Okay? So that's how you find those different pieces. Now I want to ask you a question. I'm going to type in a definite integral there and see if you can tell me what the answer is going to be. So my first one is I'm going to ignore this point right here, and I'm just going to go from left point to right point. So what do you think I'm going to get for an answer for this? Pause this and think about it before I press enter. Thought about it? Here we go. 0. Yes, the two areas cancel each other out because one's positive and one's negative. So this will not find the area for us because this top minus bottom is a bottom minus top for the other scenario. What if I do this instead? What if I type in the absolute value? And I do from the left to the right, and I got the absolute value there. What am I going to get? Any ideas? Is this going to work for us, 8.405, or is it going to give us 0 again? What do you think? Oh, it does work. So I can avoid dealing with that intermediate point if I can do this absolute value thing. If you have your calculator, works great. If you don't have your calculator, you still got to split it up into the two different intervals with the third point. What if I put the absolute value around the whole thing? What's that going to give me? What do you think? 0, 8.405, something else. Here it goes. There it is, 0. So it is exactly the same as this. Must be, because I just take the absolute value, yeah? So be careful with how you use those absolute values to make sure that you do use it correctly. So last one, if I take the absolute value of, and this scenario is top minus bottom for the first case, I believe. And this one over here is 0 to 2.02. And this one is, it's the same orientation, both of them. And then I did absolute, absolute, absolute. amongst each piece. Will that work? What do you think? Yeah, that does work because I used the bottom minus top, but then I took the absolute value of the individual piece to make it work. So you can use absolute value around these things, but you just have to make sure you do it correctly. I think the best way is this one right here, the absolute value inside, and it goes right over that 0 point. All right, I think that's enough of this playing around. And I have one more example on there. You can either do that in class or I can show that to you very quickly. So without using a calculator, we want to find out the area between any of the two sections between the sine and the cosine. So you solve the intersection points. Sine of x is equal to the cosine x. Here's the picture. So this would be a pi over 4. This would be a 5 pi over 4. I chose this particular section. Might be similar to that one too. So then the area is going to be pi over 4 to 5 pi over 4, top minus the bottom. Now if I look at this, that is the sine, that is the cosine. If I made a mistake here, I could do the absolute value of this if you wish. All right, and so that's the setup. That's what you end up getting. I think I do have an answer here for you too. Nope, I lost it. And I found it, and it turns out to be 2 square root of 2. You can do this one by hand, or you can do this one with your calculator. All right, I hope you enjoyed this. That's area between two curves, top minus bottom. Right minus left. Remember, if you do it in Y, then it is in Y. Thanks.